Good afternoon again, everybody. Happy Monday. My name is Blake Kinney, and I'm the Program Director of Energy Security and Resilience Programs here at NASEO, the National Association of State Energy Officials. It's my pleasure to welcome you to this webinar with Green Mountain Power and Core Power on their NOMAD Mobile Energy Storage, a new frontier to strengthen resiliency. Kelsey, if you don't mind, go on to the next slide. So just briefly, before I introduce our panelists, I wanted to remind everyone of a few housekeeping things. This is a Zoom webinar, so only the speakers and the moderator will be on the screen. And additionally, as you likely heard, this webinar is being recorded. We will have time for Q&A after the presentations, so please enter questions into the Q&A box and we will address them at that time. So to introduce our panelists, we have Mr. Jay Bellows, the President of Core Power, and Mr. Josh Castonguay, Vice President of Innovation and Engineering at Green Mountain Power. So to start things off, Jay's going to give us a presentation, I believe a short video. I'll turn things over to you, sir.
Thanks, Blake. Are we doing the video or presentation? Let's see which comes up here. All right, this is easy. I don't have to say anything, Blake. So I guess we just hit play and sit back. Thank you. At NOMAD, our goal has always been to make utility-scale energy storage mobile. Throughout the mid-2000s, we started identifying systems that would get put into place and be used for a very short amount of time. So what we thought was, it seems like a huge waste to build a multi-million-dollar system, have it sit in one place and only be used for one purpose, one customer, one site. So we started working on ways that we could mobilize energy storage. We do this in different ways, starting with our rolling chassis. We have three different sizes of rolling chassis: a 2 megawatt hour, 1 megawatt system, which is our large. Our mid-size system is a 1.3 megawatt hour, 500 kilowatt. And our small system, which is a 660 kilowatt hour, 250 kilowatt rolling chassis. We also do drop boxes in varying sizes. Drop boxes are designed for longer term deployments, whereas our rolling chassis can be moved every single day of the year, designed for movement, designed to be implemented and activated very, very quickly. When you're looking at the different types of applications for energy storage, we're talking about peak avoidance, frequency regulation, market integration, disaster recovery, resiliency, redundancy, all the benefits in the benefit stack. The only true restriction for energy storage has been geography. So what we did is we alleviated that restriction. Now we can move systems all over the country, all over the world, with very fast deployments, and make sure that we meet all of the requirements and needs for energy storage. We would talk to all of our partners at the time. No one would allow us to move batteries. In the process, we identified a lot of shortcomings that would prevent us from being able to do that. One of which, of course, is pretty significant, and that's the batteries. We had to find all the ways that we could prevent seismic activity. Batteries that are not meant to move, how do we make them move? And in so doing that, we started with a chassis that's built for a mobile MRI machine. MRIs are built on magnets, so they're not allowed to move beyond a certain variance, and that's where we started the system. So what you see here is a chassis that's incredibly rigid, also with an air ride system that prevents any type of overing of seismic activity. So this gives us less than 1 degree of variance in movement when we move the system. You'll notice that this system is actually not a box sitting on a trailer. This system actually is completely integrated. The sides are built into the trailer. The rack is designed to interact with the skeleton frame that you see here. All of that interacts with the foundation of the trailer. All of them were purpose-built to work exactly where they are inside the trailer for safety in the system. The entire enclosure is designed for movement. It's designed to move energy storage, not like a lot of the things that you're seeing on the road today that are a box on a trailer. The trailer is not designed to do anything different than hold heavy equipment. We didn't want that. Safety comes first and foremost for NOMAD, so we wanted to make sure that this was entirely safe all the way through, built to be able to be moved as much as it wants to be moved, while also keeping the integrity of the system intact. We have multiple forms of HVAC. So we can control the environment at all times at the large scale level for during operation. And then we have small HVACs that are designed for movement. If it's being moved through the desert, has to be stored there for weeks and weeks, we have the ability to supply air conditioning to the entire system to keep it temperate inside. When we build these systems out, we want to meet all of the code all the way across North America. So everything's built into this. We have fire suppression, dry deluge system, which is an active system but completely dry. We can attach a standpipe to the back and it can go into the sprinkler system. We have a static system in here, which is a dry agent, and then there's also off-gas detection, as well as a lot of other safety systems with alarms built in on everything that you can think of. Even if someone comes and jiggles the doorknob, we know about it in our knock. These can go out everywhere in the world. We can see where they are. We have satellite connection to all of them. We know how fast they're going, where they're going, why they're going there, how long they sit, what's happening as a standard for the system. But as the operational parameters, we have all of that coming back to our network operating center. This is really important for our customers to know that the system's operating the way it's supposed to, being able to control it, and then integrate different forms of operation for what they're looking for in that day. These batteries are actually a high C rate battery. They're 1C. You're able to do all types of different applications with these systems. These can do fast EV charging. These can do frequency regulation, grid integration. Of course, they can do all of the peak avoidance. Additionally, for off-grid applications, this is perfect for a rolling microgrid. There are truly no limitations when it comes to energy storage and nomads on the road. Actively moving with energy if necessary allows for very, very quick DR, allows for recovery of significant events that may happen. It also gives utilities the ability to offset power outages, whether it's during an outage or during construction, maintenance, or anything that they're trying to do at a system. Great. So I guess what we're going to walk through some slides here real quick as well. So if we can go to the next one, this is the picture you see here is a mid-size Nomad. It's 1.3 megawatt hours by 500 kilowatts. So again, kind of a little redundant to the little clip that you just saw. Ultimately, our goal with building these were, getting away from what we have seen over, our 50 plus years as the only restriction for ESS is the ability to move them, right? And right now, especially when you're doing grid scale, which is a variable term, but generally speaking, large scale energy storage, it's very, very difficult to move those. It takes quite a bit of time to come to a fixed site, take the whole thing apart, move it to another site, recommission it and get it going. You're looking at the very least, weeks and weeks. So the goal would be to set energy storage up so that it can be moved around and be made available for everybody. And it really started, we were building large scale systems that were designed to work for essentially a month to meet a peak demand event that was happening. And then the systems would sit dormant for the remaining 11 to 12 months, or 10 to 11 months rather, that weren't being used. And so that's what really triggered this whole thing. And with the need for storage really to be everywhere, the thought process was, why not share the asset? And as we began to start talking to customers and companies, we would learn more and more about potential offtakes. And we're really fortunate in Vermont to have Green Mountain Power here, one of the most, if not the most innovative utility. And we started talking to Josh and his team kind of early on in the process. I would say even a year, maybe longer before we even started making them, to just kind of get an idea of, what would be the best way to think about use cases for these things with utilities. And that led us to, really being able to fast track it and move forward with the systems. So if we can go to the next slide, I'll just blow through these quickly and then we can kind of move forward just because of that video that was done. But, our initial test run on these, we wanted to see what type of movement was going to happen inside the system. And as I talked about in the video, the systems themselves were designed to be moved. And that's a big deal because we're taking essentially power batteries and making them, they're designed to be stationary, making them move. And we did do some initial design changes on the modules themselves into how they integrate into the racks. and then the racks into the skeleton frames that I was talking about in the video. But it was a significant engineering process to get, to the point that we felt comfortable that these were going to be safe and productive in how they operate. And so our first test run was just over 6,400 miles, essentially went across the country through the southern part and then back up through the middle. And, throughout that process, we were just really, really happy with the results. We didn't have a single screw come out of place. The whole system operated everywhere it went as it should. And the communications back to our NOC were seamless, which is what we were looking for as well. So since then, we've done about 43,000 miles, but an initial test run on that system of over 6,400 was substantial, and what we needed to have happen, for us to feel comfortable in that process. So next slide. I talked about our network operating center quite a bit in that little video, but ultimately at core right now, core power, we design and build the nomads for Nomad, or at least the initial systems, and we bring it all back to our network operating center where we can monitor, maintain, we can operate the systems. Core on the solution side of the business has been around for over 50 years and has been doing interactive activities with their solutions worldwide for over 30 years. So we've been able to take all of that experience and build it into our network operating center. So again, we monitor, maintain, we can operate the systems. We have market integration. We do all kinds of AI in there as well. So it gives us not just continuity and operational security, but also make sure that we can use the Nomad when, how, and why it's best needed, whether that's for operational needs or financial needs. Next slide. And then, we have a couple of case studies in here too, but one of the big ones is, as we see the EV market emerging and growing quite a bit, one of the things that we have to overcome to support the EV market is really the concern and fear of inability to charge. And so what we wanted to do, we began to, for lack of a better term, accessorize the Nomad. So we have secondary trailers that can go with them that will have EV chargers on it. We have mobile transformers. We do all kinds of different things because the grid is interactive at different voltage levels. So what we wanted to do with EV charging was support that. And the process to build out EV charging can be substantial. And whether that's the permitting and our interconnection processes or whatever it might be, it can be timely and expensive because you're talking about building up infrastructure. So the thought process for using these systems for EV charging is essentially being able to solve a short-term problem while a long-term problem is being built out, or even to be able to subsidy that problem as growth happens. And one of the things that we're talking to a lot of different groups about is different times a year in different places across the country, there's an increased demand for charging. So being able to subsidy and bring in extra resources to charge could be a really big deal. So that's what we did out in California with Southern California Edison, and we'll be replicating that quite a bit across the country. Next slide. Well, actually, this is one that we did with Green Mountain Power. Josh, are you okay with me kind of stealing the thunder on this, or do you want to tell you? Okay. I hate hearing my own voice, so I'll just keep going quickly. Basically, one of the things that in talking with Josh and Green Mountain Power we learned about is all the ways that kind of just having stored energy at the ready can be really beneficial. And this is a great example. GMP did line maintenance, in a pretty significant neighborhood area, and it was going to affect about 230 customers while they're doing the work. And instead, they brought in the Nomad that they purchased, which is a large Nomad, about 2 megawatt hours, brought it to the site, integrated it into the grid while they were doing the work, and none of their customers had an outage. And what's great about that is the mindset for energy storage has grown so much so that originally when we talked about just offsetting peak demand events, the kind of the best part of the Nomad is it can still do all that while doing all of these other things as well. It kind of becomes a bit of a Swiss Army knife. So, and I know Josh has used it for other things too, including some CNI applications, which were really great as well. So next slide. Oh, and here's the CNI. I'm just gonna keep stealing the thunder, Josh. I apologize. And this is a great example too. It's a skincare company in Essex, Vermont. They were doing some upgrades to their infrastructure, and they were able to bring that same Nomad there and support the system. Support the entire manufacturing facility while it was down doing some maintenance as well. So again, just another use case within that same kind of application mindset. Next slide. And that's it for me. So now that I took all your stuff, Josh, it's your turn, buddy. Sorry about that.
Yeah, those were the only 2 slides I had, so that's it. So good to see everybody virtually here. I'm Josh Castlegate, Green Mountain Power. I lead our innovation, energy transformation work here, and along with some other teams at GMP. And I've been here for 20 years, which is crazy to say out loud, but so be it. We can kick to the first slide. So I think I just have 2 or 3 slides here, quickly hit what GMP, what we have going on right now, kind of who we are, and talk a little bit about Nomad. And unless am I supposed to advance the slide, or will someone else? There we go. Perfect. So just again, we cover about 75% of the state of Vermont, which again is still small in the grand scheme of investor-owned utilities. But we're able to kind of leverage that size, that scale, and really push on the innovative side of things and how we're delivering energy, delivering resiliency to customers, reducing cost, reducing carbon, and everything we do. Something that's become very, very apparent, as I'm sure anybody in the utility space is painfully aware. Anybody in the energy space is that storms are becoming more and more frequent. The severity of storms are only escalating. We, in Vermont, we had, again, in just a few short years, some of the worst flooding and precip events that this state has ever seen. For GMP, we've had, in the last 5 or 6 years, 6 or 7 of the worst storms in the history of our organization in terms of customer impact. And that's either heavy wet snow, because those temperatures are hovering right around that freezing mark, high wind events, and a lot of things in between. So the need to really help bolster resiliency, reliability is just only getting stronger, especially as we look at electrification being a key component of decarbonizing. So something that we just put together recently, after a lot of work from a lot of teams here, is our zero outage initiative, which is exactly as it reads. Our target is, customers will not be experiencing outages by 2030, and that doesn't mean the system might not have impacts, but customers themselves will stay powered up. And it's a host of solutions with a lot of stuff that's been going on, but has become much more cost effective, like undergrounding of the distribution system, hardening of the overhead line system. And then the big one that's more recent is the ability to use energy storage in this. So something GMP has been doing for the last, going on 10 years now, has been deploying programs around battery storage, which started with small systems in homes to larger scale distribution systems. And now we're excited to be able to roll in this mobile aspect to this whole solution. We can kick to the next slide, please. So specific to mobile. So obviously, as we have been on our kind of journey of leveraging storage, we've learned a lot. We've learned a ton of what you can do with battery storage. And I've said it a few times, it's an incredibly flexible resource from a grid standpoint. It's one of the most flexible tools that you have. It can be a load, it can be a source, it can be a power electronic voltage stabilizing device, it can do frequency regulation and other market values, and it can ride customers through outage events, provide that reliability and resiliency. The most, one really amazing thing about storage is that it provides that resiliency, reliability that you get from doing the undergrounding and doing the storm hardening, but it also pays for itself through these other values that you can take advantage of while the system is not performing some of those resiliency, reliability benefits. So when you take all of that and now you put it into a system that can be mobile, you just added another host of benefits to a system, because there are some key locations where a stationary storage may make sense, but there's a lot of locations where I might only need a system there for a few key times during the year. Or, in the cases that Jay highlighted, where we were able to support customers during planned events that otherwise in the past would have either been a scheduled planned outage with the customer, or the customer would have to go through the expense and planning to roll some generation on site and get that up and running, and then take the planned outage to fix some of the system there. In the case of Twincraft that's mentioned here, they have a really specific process that relies a lot on clean water and a lot of processes that you can't just shut down really easily. So being able to keep that going, leveraging the system was incredible. And as Jay mentioned, the town of Proctor, that's an entire town that we're able to keep up and rolling while we had to do some emergency work, where in the past we would have had to schedule an outage, work as quickly and safely as we can, and then get it back up and running. So it's huge, and the opportunities are just growing as we move into this. Something that we are doing. In fact, we can jump to the next slide because I think this hits, as we look down the road here. We're starting to think about, okay, now we've got these mobile systems. The mobile EV charging is a phenomenal solution, just like the pilot you talked about, Jay, in California. As we have areas that need charging and the ability to get charging while other systems may be down, that's a great resource. Something that GMP is doing is actually just designing into our standard line construction as we rebuild lines for either a zero outage work or anything else. Anytime that there's a location, let's say, that is suitable for a Nomad to park, it could be a pull-off, could be some area, we're going to design in a simple interconnection point into the distribution system there. That can be, that way the system can be rolled in, plugged in. It'll have been, studied from a load flow standpoint to know, like, yep, this is the size system we would need here. We plug it in and we can carry the customers downstream from this location in the event something upstream happens. So just starting to work that into general design thinking when we look at the transmission and distribution system. It's, and as Jay showed in some of their, one of the things that we learn as we deploy it is how to get quicker and quicker and quicker at interconnecting and integrating the system to the grid, to the hope that we're going to be doing this thing, in less than 30 minutes, we're plugging it in, firing it up, and we're carrying customers. So incredible solution. I mean, I think, as storage has been a key part and will continue to be a very key part of our ability to provide resiliency, reliability to customers, especially again, as we decarbonize, electrifying, and providing customers with this resource. And as we manage, last thing I'll say from a storage standpoint, and this is where location really matters, is that, there's a lot of solar in Vermont, in California, and scales are different, but in terms of the amount of solar or the amount of load we have here, we have a really large amount. We have days where we could be feeding most of this Vermont load just with solar. And you now need to start to think about how are we going to manage those resources, to shift them around during the day, during the week. And certain locations, it may make sense to have some storage there seasonally. Maybe it's just during, key months where we have higher solar production, so we can move things around and start to leverage that energy at different times of the day. The peak is, let's say, is at 6, 7, 8 p.m. in this location, and we need to alleviate the substation just during May and June, during big solar months. We can use systems like these during those periods. So the mobility is really key when it comes to helping our customers there. And then we're excited to be working with NOMAD on a DOE grant recently to get more units going and really help communities around Vermont. We're psyched that they're in Vermont too, of course. That's awesome. There's benefit there. So I think that was the last slide I had.
Great. Thank you, Jay and Josh. Jay, before we move over to questions, did you have any other comments or things you'd like to add to what Josh said?
No, he did a much better job than I did. So I'm feeling good about it. Thank you.
Something that really stands out that Josh mentioned is that there's a few locations that could use some help 24/7, but there's a lot of locations that need temporary assistance. And I think the mobile aspect of this technology is key. I've got a few questions, but we've got several in the Q&A. So I'll start at the top, and gentlemen, just feel free to answer. This may get answered, but I wonder how long the 230 electrical users could have been powered off of NOMAD. How long would it take to recharge in that condition and in that setting? And this may not be able to be shared, but any information on cost for the 3 sizes?
You want to talk
Sure,
about
I can hit Proctor. Yeah, no, it could cost you, Jay, if you'd like. So we ended up carrying those customers for, I want to say, around 6 hours. I mean, of course, it depends on all the factors around the loading and what's going on. And I believe we still had 10% or so left in the tank per se. So we were using the 2 MWh system, 2,000 kWh system. We looked at what the loading was ahead of time and kind of got a sense of, okay, this duration is going to work for us. So really, depends on the loading and downstream and what you're feeding and what the peak is and what you're expecting. We carried through, I think, again, 6 to 7 hours there actually, and then had room for another few hours of buffer. And recharge time, I mean, if you can get the full megawatt of charging power, depending on where you're plugged in and everything, you're looking at a couple of hours recharge for 2 MWh system there.
And then as for the costing, those are all being adjusted as we speak. So I don't have an actual cost to share, but if you want to reach out, we certainly can talk through it with you and see what we have that would fit your needs.
Josh, in that use case, could demand response actions also be put in place with customers in addition to a NOMAD system?
Yeah, absolutely. So one of the things we did that evening, I mean, part one was the outage was scheduled for the overnight for that specific reason, the lightest load possible. But number two is interesting. So we have a lot of customers that have residential battery storage that we leverage for other programs and things. One of the things that we ran that night was during the same window Nomad was running, we were discharging those storage systems. So essentially creating a further reduction of load needing to be fed by. So the short answer is yes, you can leverage flexible loads and DR during key times if needed. And that worked really well.
Great. Next question. This is key for state energy offices. Would your technology be eligible for 40101D grants or GRIP awards? What are the bigger question, what are some funding avenues that can assist in paying for this technology?
So yes, they are eligible for that. And if anyone has questions on that, we'd be happy to help them kind of walk through it and see what applications they're looking to use it for and go through that process. There's lots of ways, there's lots of opportunities right now in the entirety of energy storage. I would say in the entirety of energy, really in finding ways to get funding and helping make projects come to fruition. So there's lots of ways right now. I mean, I don't know them all off the top of my head, but certainly, as Josh talked about earlier, we have a joint grant that we were awarded between the two companies. And there's lots of those out there, resiliency grants, there's PACE awards, there's lots of different opportunities. And it, again, is going to depend a little bit on the application, right? There's EV charging things, there's lots. So it depends on what you're looking at. But in general, yeah, there's lots of opportunity for funding.
Great. Josh, anything to add on that question?
No, just as Jay said, I mean, we're looking at GRIP proposals that include a mix of mobile and stationary storage. So yeah, we expect that to be all included there.
Great. That's great news. Next question. Has the NOMAD system been approved for an IOU through the regulatory process, or have there been hurdles for that?
Would you say that one more time? I'm sorry, I missed the.
Has there been NOMAD systems approved through a PSC or a PUC for use by an IOU, an investor-owned utility? And if so, any hurdles that you may have identified through that regulatory process?
Yeah, it's been approved to be used. We have them really crossing the country being used at different utilities all over, whether that's a co-op, a muni, or whatever. Yeah, there's really no restrictions right now at all that I'm aware of. So we haven't run into.
Yeah, we're an IOU.
Oh, that's right.
Yeah, so yeah, at least here. I mean, we so yeah, short answer is yes, and when you can show, it's helped that we've kind of built up a battery storage set of programs and really show the value. So really having mobility just adds to it. So yeah.
Great. Next question. It appears the main use now is to charge NOMAD with grid power and then discharge as needed. Can NOMAD be integrated with distributed generation and storage also For example, during an extended water grid stress or outage, be able to charge locally with solar or other resources to operate as an islanded microgrid. And a follow-up question for Jay, any consideration for non-lithium batteries in the future, such as flow batteries or other options?
So yes, it's designed to work with any form of generation. So we've had lots of conversations with different recovery groups, whether that be FEMA or otherwise independent, about doing just that, being able to charge, move it to a site where it's required. And that, as Josh was talking about earlier, he was discussing an application for solar, right? In Vermont, there's times where there's much more solar penetration than others, and being able to take the energy and move it to different locations. And I think anyone who's kind of driven through the central part of the United States has seen a lot of wind energy at time get curtailed, right? Because there's not enough offtake or consumption for that. So being able to then take that potentially and move it and not curtail the generation has real benefits to that. So it's designed to take multiple forms of generation. In fact, it can be co-gen, meaning multiple forms of generation going into the same system, if need be. So certainly can do that. And then as far as other chemistries, we're always looking. Our partnership with Core Power gives us dual chemistry on the lithium side, LFP and NMC. The issue is always going to be weight. And so when you look at flow batteries, they're very, very heavy. And there's moving parts in liquid. And while the systems are designed to mitigate seismic activity within movement that's happening every day, it still would be water, and you'd be not water, actually, it's electrolyte, which is even worse, but it would be concerning, right? And you have pumps and other things in there too. I think that would be probably pushing it a little bit on the flow battery technology. And but as new types of batteries come into play, I think you'll definitely see NOMAD kind of adopt that technology, including potentially saltwater batteries. But I'll tell you again, weight and ability come into play, right? Lithium right now is pretty potent when it comes to its ability to charge and discharge, and with how light it is as well. There's significant benefits to that. So
Before we get to the rest of the questions, just had a quick question. We keep talking about weight and the fact that these are mobile. Just briefly, what about the vehicles that are used to move these? Do they have to be commercial motor vehicles like that larger 18-wheeler size truck?
Well, with the large ones, they do. Yeah, I mean, these are heavy, right? I think, Josh, you may know this better than I, but the large is like 68,000 pounds, right? Does that sound about right? And then the mid-size, is right around 50. It's in the mid 50s. So now we're making them smaller and more physically compact, being able to hold the same amount of energy. So those weights will come down, but you're looking at a large scale, like a tractor trailer to move those. Now they don't have to be, an internal combustion engine, right? There's lots of emergent technology on the EV side for those, and that's the goal. Hopefully, at some point, is to have an EV tractor, pulling it, and potentially even pulling power from it at the same time for long duration. So maybe a future application there, right? We'll have to see.
Very neat. Very neat. Moving on to our questions. Jay and Josh both mentioned long-term power storage. What is the realistic loss of power over time when not used? So any degradation there?
You want to go, Josh? I've been talking for a while, so.
So this might be in your court. You mean in terms of if the system is just sitting there charged, will it lose? Jay can definitely hit the specs. The way that we look at our storage systems is we tend to leverage them, a decent amount. They're not usually sitting for long periods of time. And then they're kind of being topped off, or we're doing peak events or frequency regulation. There are like cycle losses, obviously, round trip efficiency. Anytime you discharge and recharge, there's some losses. In terms of sitting there and holding charge, I don't know, Jay. I don't know the answer to
It's
that
minimal.
one.
Yeah, it's going to be minimal.
Yeah.
And I think to Josh's point, if you have one, kind of the whole point of the mobility is to make sure that it gets used a lot, right? Like you're opening up applications, for this. Whereas a standard system may discharge, 120 times in a year. The goal for a mobile system would be, 300 times a year, potentially, maybe more. So, but to answer the question directly, you're looking at very, very, very minimal loss as it sits over a long period of time. So, But at the same time, to Josh's point, you don't want the batteries to degrade either, right? There's a degradation schedule that comes with that, and how much a cycle is, affects the degradation, but also calendar affects the degradation. So, if you're going to have a battery sit for a long period of time, you're going to want to lower the energy density inside of it and get it probably between 30 and 40% state of charge, and let it sit at that point. It makes the batteries a little bit happier to sit there over a long period of time. And then charge it back up again when you're ready to go. But again, it's just really going to depend on, what you're using it for and what the plan is for the next movement as well.
I think something I'll add to it, we didn't hit, was we have these docking stations. So think of it like kind of the home base. So when this mobile system isn't out doing some mobile function, it's kind of back at the docking station plugged in, and it's acting just like a stationary storage system. And we're leveraging it for all of the typical peaks. So it's not like we have it kind of parked outside, not connected at all. It's always connected somewhere. It's just a matter of, where and what's the use case.
Interesting concept. It potential to continuously provide value, but increased value depending on how and when it's deployed. Moving on to our next question. What would be your top recommendation for state energy offices as they can consider mobile storage, and any policy or regulatory hurdles related to that? So top recommendations for state energy offices considering mobile storage and any policy or regulatory hurdles.
Yeah, I think, something that GMP and Vermont regulation has really benefited from is the ability to pilot. So something we have a multi-year reg plan. We're also, this matters a ton, a vertically integrated state. We're not deregulated, so we can manage generation directly, all the way down through to the customer level. Something that's in our regulation plan and I've shared with other regulators across the country is the ability to pilot. And what that does is it moves you out of the full-blown tariff world in limited instances to test new things for customers. Just because we know, the full-blown tariff world can take a little bit of time, and as technology is evolving, sometimes that lag is a little too much. So through piloting, we're able to test storage, confirm it works, and then move to the more permanent or commercial tariff approach. So I've been a big advocate for the regulatory world to allow some of that piloting, to make sure we look at it pretty simply. If we're doing something, does it make sense for the customer that wants to do it? Does it produce a benefit for all of our customers, regardless of them participating? So everybody sees some kind of benefit through reduced cost of service or resiliency. Does it provide us with a new flexible resource to manage a much more decentralized dynamic grid? If we kind of hit those things, then we look at, should we pilot something here? So that's the pitch I would make, is to leverage that kind of piloting in your regulation to test things out, get data, get results, and then iterate on that. And that's worked really well here. And we partner with the state and with our regulators as we do these projects. And rightfully so, they scrutinize the work that we're doing to make sure that we're all aligned, and that's been a really good process, and we'll continue to do that.
Yeah, and I would just add to that. I mean, GMP, as a Vermonter myself, we've been very, it's a huge benefit to have GMP as our provider, right? They've really pushed the envelope on a lot of things, and I think through that pilot process that Josh was talking about, and as an off-taker of GMP's energy, I can tell you it's only benefited me. So I think, as you look at those processes, that's a key way of doing it. The other thing is just, we haven't run into a restriction on ESS at all, really, across the country right now, especially as we're seeing really the benefits. I mean, energy storage has been widely adopted. I think at this point, it took a while to get there, I can tell you that, but it has been widely adopted. I think, with mobility, I think just the benefits far outweigh even that long-term adoption process. So it's been accepted really, really quickly because ESS has been accepted really fast, or it has finally been accepted to the point that it is. So, and again, the systems were designed to meet all 50 states requirements for energy storage. So it shouldn't be much of a process at all to do that. But again, it's going to depend. And we're seeing a lot more kind of rules and regulations come out within energy storage as a whole too. So, the goal for Nomad is to continue to stay ahead of that and make sure that we're meeting all the requirements as they evolve.
Great insight from both of you. Next question. How is the system intended to be priced? Is it an outright purchase, a lease agreement, or some other form?
Right now, it's an outright purchase. So we've certainly talked about doing leasing programs, and that might be a step that we do as we really start to roll out more, no pun intended. As we get more product out there, we may move into that realm. But right now, the demand is really high on the purchase side, so we're going to continue to do that as we manufacture more and more of them. But potentially long term, moving towards a leasing product might be in the future.
Knowing that oftentimes different municipal utilities and cooperatives will partner together, those use cases with either one of those entities or organizations, let's take a co-op, for example. Are there any use cases where maybe a state association or a group of co-ops are utilizing the Nomad technology versus a specific single co-op?
Not right now. I mean, we have a couple of utilities across the country that are, at the muni level that are, acquiring them. And I'm sure that there's going to be cases where they use them, where they share them with other utilities. I would only assume that. I think even as you look at groups like, for example, we've talked to FEMA and others about this, right? Because it makes a lot of sense. And for a lot of the recovery groups, they have a lot of gen sets, mobile gens that do something very similar. But you move in fuel and there's combustion and all the things that go with it. I mean, we've designed them out to they can be rolling microgrids as well. So if you can imagine tying a Nomad to like a mobile gen or any type of generation, but let's just use a mobile gen for this instance, you're able to build a mobile microgrid, right? The gen will not, in general, the way gens work, gen sets, they run to nameplate for the most part, right? So if you have a 1 meg generator and your load's 50 kilowatts, you're wasting 950 kilowatt hours as it generates. So if you were to tie that to a Nomad, the Nomad would accept all that generation and then discharge only what's required. So you're looking at elongating a use case, but also at the same time reducing costs, reducing consumption of fossil fuels. So there's lots of kind of different ways that we're looking at integrating those into processes. So even within some utilities where there's a high use case for off-grid, they're using them for that as well. So some utilities that we've talked to are talking about sharing them amongst themselves, and I think that'll probably be a use case that we see here in the coming months and years.
Very neat, very neat. Next question, good question. How do you make the ground to the system when you are installing?
Well, as Josh was talking about, they have docking stations. Like GMP has a great docking station that's not far from where I'm sitting right now. That's all, an active ground there. There's switch gear, transformers, everything's there. If you have a mobile transformer that goes along with it, remember, these are mobile ESS. So they go to the other end, what we call the other end of the inverter, right? So the offside of the inverter, and then it goes to a transformer and then to the grid. Well, in general, when we design these, we didn't put the transformer inside the system. We have a couple of designs that do that, but in general, we didn't do it because the integration into the grid in the US is all over the place, right? So what we didn't want to do is design a system that's made to be used everywhere and then say, well, you can only use, it in these 3 spots because, that's how it lines up with the integration into the grid. So that's why we've accessorized and have mobile transformers that can go along with them. And those themselves are grounded as well.
Great insight. Next question. What are the main lessons that each of you have learned from this product at this point?
You go ahead, Josh. I'll follow you.
Sure. Yeah, I think, the thing we're learning every time we deploy is how to get faster at interconnecting it. That's one of the key things, right? We knew that, you still have to assure, like to the question about proper grounding and that you're going to get stable, clean voltage under the system. It's going to be safe. And, and protected. So our first few interconnections, we took extra time to make sure we're hitting all of those things as we should. So the things we're learning is how to get quicker at that, how to build. We're looking at building these trailers that essentially include the interconnecting equipment and it's set of cables in and cables out. And we're learning. We have what we call mobile substations that we've been using for decades that we can roll in, bypass a substation, but it's just a transformer. It doesn't produce any energy. All it is going around the sub, taking what we know about that and applying it to the storage. So I would say, that, and then communications and just, what are the different ways we can communicate with the device while it's deployed out in the field through either cellular or, the connectivity where we're able to kind of see what's going on in real time. And so, yeah, I think we kind of knew what the use cases were going to be in terms of learning that aspect. And it turns out it's exactly as we had hoped. And we can see even more coming. So that piece is going to be great, designing in that interconnection and learning how to just connect it quicker and quicker every time.
And from our standpoint, I think the biggest thing for us, we're still learning every day. I think, it's going to be like Josh talked about, use cases for us are the things that we're learning about. As it's been out there, hearing from potential customers what their needs are is really interesting. And I think if you look at just the IRA in general, and this is relatively self-serving, to be honest with you, is that we're looking at increasing our supply chain for battery manufacturing here in the US, right? That includes mining and processing and all the stuff that goes along with it, whether you're doing anode, cathode, separator, all kinds of stuff that we're working on here in the US as part of the IRA. To do that is it's really, really electrically demanding, right? You're talking about huge electrical loads. And so, how you overcome that today is by using generators, right? So gensets, you're moving, fossil fuels to get to a site. If you're lucky enough that there's natural gas, you do that. But it's not efficient, as I talked about earlier. And we're working with a lot of groups on using the NOMAD for that process, right? So if you're going to a wind farm or a solar farm, filling up and then moving it to the site to power, equipment, you're getting away from internal combustion, equipment and going towards a greener mindset in electrical equipment. So there's lots of new applications that we're talking about. The marine realm is an entirely new one that, we really didn't think of when we first designed these systems, but these are marine grade enclosures. So it makes complete sense as the shipping world is going towards electric as well. You're talking about a big impact on the environment if you can go electric away from diesel in that aspect too. So it's really use cases for us, things that we never would have thought of. But since we've been, it's been out there and people are seeing it more and more, it becomes kind of a bigger deal. So we're learning every day and kind of the new use case is actually pretty exciting to see how we can have an impact there.
Great comments from both of you. Our next question, is the NOMAD technology an eligible technology with FEMA BRIC and hazard mitigation plans? And how is that, if so or not, in relation to a BCA, benefit cost analysis?
Yeah. To my knowledge, it is. We're having lots of conversation with a lot of first responder groups, as well as FEMA itself. So yes, and I think as a use case for the NOMAD, it makes a ton of sense. As Josh talked about earlier, the ability to be grid integrated or integrated into a load very, very quickly is huge. And I think if anyone's ever used generators as an example, I keep talking about them, but using those like mobile gensets, for example, it's a process. And if you've been around a diesel that kicks on, that's a 1 megawatt diesel, there's a lot of smoke, a lot of noise, right? It gets cranking and then it goes. There's no noise impact almost at all to these. And the ability to kind of push a lot of electricity and consistent electricity into the grid is hugely beneficial, especially in those recovery processes.
Josh, anything to add?
No, I think you hit it. That's the interconnection work there, key.
Good deal. Our next question is a comment, but I'd appreciate any reply that either of you would have. This comes from Greg in Oklahoma. We would consider using State Energy Program BIL funds to use on this for rural tornado disaster response and possible EV overage in use for EV storage and in rural areas. And, we've talked a lot about use cases, and just curious, any comments or thoughts using the NOMAD technology in that setting for rural tornado disaster response and possible EV overage?
Yeah, I mean, the tornado disaster response, absolutely. That's, like I said before, the weather impacts, for Oklahoma, I can imagine tornadoes and hurricanes, and here it's ice storms and also hurricanes. And that post emergency response to be able to either power up a shelter or even provide a central location to go plug into and power things up. Absolutely. That to me, that's a key use case, kind of similar to what Jay was talking about with FEMA and what they typically bring in. And I'm not totally sure I understand the EV overage. Was that, you mean like charging EVs or
I believe in charging and then storing the energy that the car is charged with.
Yeah, so yeah, if using, so either a couple things. One, it can be used, in my opinion, it could just be used as a stationary device that you roll in and folks can plug in to charge off of it if that's the need. Or if there's a localized issue where you're getting a major EV charging peak that you need to manage certain times of the year, that's a good case. Again, knowing that it can be a source or a load, you can think about it in both directions. And if you need to be soaking up energy in the middle of the day in a highly solar saturated circuit, and then use that to feed kind of peak EV charging. So there's a good chance that if you're thinking up a use case that you can use storage for, the mobile thing can meet it. It's definitely that the mobility of it allows you to do all of that stuff fairly quickly, a lot more quickly than building up a new stationary storage device. So yeah, especially the disaster recovery, that's an incredible use case for these devices.
Absolutely. Jay, anything to add on that?
No, I think he nailed it all.
Good deal. Our next question, we've touched on different design and technology inputs into the NOMAD, but do the mobile inverters travel along with the other bots, the complete system?
The inverter's in the complete system, correct? Yep, exactly.
Excellent. Next question. Have you had interest by critical infrastructure facilities in purchasing NOMAD systems?
We have. Yep. Quite a bit actually. And I think that's going to continue to increase for sure.
I agree. What about data centers? Any interest from that group?
So a little bit initially. I think there was maybe a year and a half ago a big push on the kind of the mobile mindset towards data centers. But I think for the infrastructure required, it's really hard to do that, right? They really don't even call them mobile; they call them non-permanent, right? So imagine like 40-foot enclosure becoming a data center. There's lots of groups that do that, although it's slowed down a little bit. Really, at the data center level, you're looking at more fixed assets than mobile. But that being said, we actually have recently designed some systems that are hybrids. So if you have multiple data centers, for example, and the loads kind of wander a little bit throughout the year, you can have a fixed system that is sized down and use a mobile system to kind of bring it back up. And then as the requirements, change per location, you're able to reduce the total fixed asset down significantly and share the mobile asset. So we've had a lot of conversations about that of late, just based on the varying demand, the load demands, as well as the cost of electricity at certain times in different areas.
Excellent. Our next question, does the mobile system run with 100% charged batteries, or is it at a minimum level?
They can go from 0 to 100 and 100 to 0. So I think that's what they're getting at. It's not like an 80-20 application.
What about when transporting? Do the batteries, due to any safety regulations, do the batteries have to be at a certain minimum level?
That's ultimately going to be the owner's choice. So there's right now there's no requirement at that. Josh, I don't know if you guys I think you guys roll at like 30% state of charge. Is that accurate?
That's my understanding. Yeah.
Yeah, I think so. And we like when we deliver batteries, you know, to be built at our manufacturing site at 30% too. But if a customer wants to, like we talked about a couple of use cases early on where you're tying to solar or wind or even hydro, rather than curtailing the asset, the generation asset, you know, loading a Nomad and then driving it to another location, it can absolutely be done at 100% state of charge. It's designed to be moved at any state of charge, so it's not an issue. But if you're looking at long-term deployments, like when we drive across the country, I'm pretty sure we do it at 30% as well, just to avoid degradation if for no other reason.
Great insight. We've got another question in. What is the lead time for delivery of a system, assuming it is now commercially available?
You're looking at about 6 months, most likely. Yeah. I mean, if a customer asks and it is, you know, the process is clear, they know exactly what they want, and it's a standard system, we can turn that around pretty quickly.
That's great. You know, hearing that transformer delays are multiple years out, so 6 months is near future.
Well, remember, we don't have a transformer on board, so I can avoid that problem.
Absolutely.
For the most part, right? But we do have some designs with transformers on board, but we have pretty good supply chain when it comes to all of our components, and obviously being tied to core power, and we're usually the longest delay on the supply side is with the batteries, and so there are batteries, and we're able to make those work. You know, get them to us pretty quickly.
Great, great. We just have a few minutes left. If anybody else has a question, drop it in the chat. I'll ask
I'll just, as a quick reminder too, we'll be at the winter policy meeting. We'll have Nomad representation there. So if people have additional questions, we can certainly answer them at that time.
Yes, absolutely. We've got one more question. Do you use 2 trucks, one for the power system, one for batteries, or just one for 2 purposes? So I guess what is the fleet size when Green Mountain Power goes to deploy a system?
Just so when we're pulling the Nomad, it's just the one truck, and obviously the Nomad has all the power electronics and storage on board. Then depending on what's going on, is there already a docking station built, or do we need to do something temporary? If it's temporary, we bring in a transformer, switch, and recloser. We're working on building essentially another small trailer that has that equipment on it. So in that case, you'd have 2. You'd pull the Nomad with the rig, and you wouldn't need as big of a rig, and you pull the interconnection trailer along. But right now, it's just the one truck with the Nomad.
And I think from Jay's video, we saw that it's just one truck transporting the actual bots. So good insight. All right, Jay with Core Power, Josh with Green Mountain Power. Gentlemen, thank you both for your time this afternoon and for answering the many questions we had. I certainly came in here with some idea of how this technology could be utilized, and I'm leaving with several other possible use cases to help state energy offices out. I know our attendees are feeling the same way. So again, thank you, gentlemen. To everyone else, thank you for attending and joining. Again, they'll be at the Energy Policy Outlook Conference in February, so please track them down and answer and ask any questions. I'm sure they'll answer them. So thank you all for attending, and I hope you have a great afternoon.
Thank you, everybody.
Thank you. Take care.
Take care.